Hello everyone, welcome back to my YouTube channel. So as per request, there is a request about this sum. So I'm just gonna try and solve this. So this is our sum. We have x squared dy dx is equals to 2y squared. So the first things first, we have to cross multiply it. So the dx will go on the other side. So we have x squared dy is equals to 2y squared dx. Then we set our value. Y is equals to xv and dy is equals to x dv plus v dx. So this is product rule of differentiation. So we have to substitute our known values, x squared and the value of dy, which is x dv plus v dx, and 2y squared, the value of y squared, which is x squared v squared. So next thing to do is simplify. X squared multiplied by x cubed, x squared multiplied by v, x squared v is equals to x squared v squared dx. So simplifying it, we have to divide everything by x squared so that we will have the remaining of 1 x value. So we have x dv plus v dx is equals to 2v squared dx, right? So next thing to do is combine all like terms. So I combined all the v's, and then I factored out the dx. So by manipulation, we can obtain the value of dv all over 2v squared minus v is equals to dx all over x. So the next step is integrating our values. So now we have it. Let's first do the equation on the right side. So we have integral of dv all over 2v squared minus v. So let's try. So we can factor out the v, will obtain 2v minus 1. So after that, we can proceed to the integration of partial fraction. So we will find the value of a and b. So I'm rewriting it, and then I'll multiply it by a all over v and plus b all over 2v minus 1. So let's proceed with simplification. So we will have a multiplied by 2v minus 1 plus b multiplied by v. So when v is equals to 1/2, b will be equal to 2. And if v is equals to v is equals to 0, a is equals to -1. So our b and a, we have to substitute it in our a and b constant at the top. So we will obtain -1 over v plus 2 integral of 2v minus 1, and then we have another one outside the equal sign, the integral of dv over v. So this is it. So I'll just rewrite it in another paper. So we have to differentiate it now, integrate it now. So integrating it, we will arrive with negative ln b plus ln 2v minus 1 is equals to ln x plus c. So I will arrive in ln 2v minus 1 all over v is equals to ln of x plus c. So since we have ln here, the reason why it became like that is that we have the rule of logarithm of natural logarithm, which is ln x minus ln of y is equals to ln x over y. Yeah, ln x over y. That's it. So that's the reason why I have it that way. So I wanted to remove the ln sign, so we have to put the Euler's. So e raised to c is constant, it's the same anyway, so write it that way or not, the value will still be the same. So 2v minus 1 all over v plus is equals to x plus c. So that's why that's what we arrived to after removing the ln. So we know that the value of y is equals to xv, and then there's a v, so we have to change it into x and y terms. So we arrive in v is equals to y over x. So we have to substitute it in our v value. So with it, I plug it in, and then I simplify it. So we have it. So our x will be cancelled most probably, because we could still simplify it. So to divide it, we have to reciprocal the denominator so that we can change the operation used. It will be multiplied. So our x is removed, we will be left with 2y minus x all over y is equals to x plus c. So we have to multiply everything by y. So we will obtain 2y minus x is equals to xy plus c. So let's get new paper again and continue our problem. So now we have 2y minus x is equals to xy plus c. So it can be an answer already, but we can still simplify. So we will have 2y minus xy is equals to x. So I move xy to the left and then the x to the right so that I could get positive x. So we left y alone, so we multiply 2 minus x with x plus c. So that is our final answer. Thank you for watching.